Good morning or good afternoon. Welcome to the Altanova webinar session. Today we're going to talk about underground cables online diagnostics. My name is Lorenzo Paschini. I'm Senior Service Engineer at Altanova, especially in the Tech Imp office in Bologna. You can find my contacts here below. And let me also add a few information about the webinar. At the end of the webinar, we will have a question and answer session. So I will try to answer online during the 1 hour of some of the questions that I can see in the question box that you can find in the GoToWebinar software. All the other questions will be stored and I will answer to you by email on the email that you have put in the participation form of the webinar. So I'm working at Altanova. We are now part of Double Engineering Company. Our target is to enhance the maintenance activities of our customer by providing diagnostic solution and improving the performance of the electrical asset that our customer have. We reach this target thanks to our portable testing devices, advanced monitoring system, and as well with professional services and consultancy. Altanova is a merge of two Italian companies, ISA, founded in 1938, and Tech Imp, founded in 1999 as a branch of the University of Bologna. These two companies merged together in 2017, creating the Altanova Group. Our family was getting a new member in 2019 by the acquisition of IntelliSo. And since 2021, we are now part of ESCO Technology, where we have joined the Double Engineering Company, being part of the subsidiary of ESCO for Utility Solution Group, USG. Many of you know that Double has a very long history. It's more than 100-year-old company. And through all the years, there was always an evolution in the testing instruments and systems. In the last years, there was also an expansion by the acquisition of a few other specific companies like Morgan & Schafter, Vanguard, Manta, and in the last years by Altanova Group and Phoenix Technologies. Altanova today is present worldwide in more than 100 countries. We have 12 facilities around the world. We are now more than 150 colleagues around the world, and we have a quite big sales network, and our customer family is more than 5,000 companies and professionals. The brands of the Altanova family are, of course, Double, US-based company famous for testing solution and services. ISA, that is an Italian-based company that provides instruments for offline testing of circuit breaker, transformer, and many other, also rotating machine and many other electrical assets. Morgan Schafter, specialized in dissolved gas analysis. Phoenix Technologies, specialized, US-based company, specialized in laboratory equipment, voltage source, and current sources. Tech Imp, Italian-based company that is strongly oriented to partial discharge testing and monitoring solution. And Vanguard Instrument, a California-based company focused on offline testing instruments. Our portfolio is composed by three main categories. We have a series of electrical testing equipment. So the family with all the companies has a huge portfolio of solution of single instrument that can be used, and where we provide also assistance and customer training and assistance. We also provide professional services. We can talk about installation and commissioning, testing session, testing campaign, data analysis, and consultancy. The third part of the portfolio is getting more and more market in the recent years thanks to the digitalization. That is the monitoring system portion. So when we mention monitoring system, we want to explain that it is a permanent monitoring system installed in the asset that can work in a standalone way or connected to the customer SCADA and the software systems. The assets where we work are basically whatever you can find in medium voltage and high voltage substation and plants. So we start from transformers, circuit breakers, switch gears, cables, and also instrument transformer, relay, rotating machine, VSD, and overhead lines. Whatever is an electrical machine with the complex working principle with an high voltage or medium voltage insulation, we have a solution in our portfolio to fix the issue and to find out what is the root cause to enhance the quality of the life of our asset. Today, we will talk about online diagnostics on cables, underground cables. So at first, we will present the strategies that we can have, that we can decide to follow up with underground cable and the related challenges. We will see a series of survey methods. We will then move forward a little bit more deep into information with the specific PD investigation on underground cables. And then we will have an overview of the permanent monitoring system for underground cables. So this asset is getting more and more interest in the recent years, while in the past years it was a solution used just for special application due to boundary condition, like it was not possible to install overhead lines or it was necessary to work in a very small space. Today we have the cables as the primary solution for transmission and distribution in many cities. Especially we talk about Far East, Middle East, and Europe. What are the advantages of using underground cables? Of course, we have a minimum visual impact. There is no electrical field from the asset. It's normally more acceptable for the population. And today we have efficient installation techniques and a decrease of the prices of the installation of underground cables thanks to the XLP design of high voltage and medium voltage cable. What are some of the issues that we can have with our cables? First of all, they are our asset, they are our transmission lines. So it can be hard to get out of service sessions to make some diagnostic test and to have an evaluation of the health of the asset. Because of the dispatcher needs, it is not possible to put lines out of service easily. The second problem is that such circuits are normally buried. So we don't have access points to the cable. And in many cases, especially in medium voltage, the cable route can be unknown. Instead, in high voltage and extra high voltage cable, we have few access points to perform some testing. Those are the link boxes and the termination. Or in some cases, we can have the cables installed in tunnels or the joint bays organized in manholes. So we have few more things to do, few more opportunities to check the health of the asset. We will see a lot of techniques that can be used on underground cable, but all of them have different characteristics, and we always need to find the balance between the effort of the test and the focus that we want to have on the target, as well as the balance between the information that we have from our assessment and the related maintenance action. So our strategy about the condition maintenance of the asset shall take into account the acceptable risk of fault for the specific asset, the resource allocation, and the information management from the eventual testing session or monitoring sessions. The key point is to understand that every asset will have its own acceptable risk of failure. For instance, if we have a redundant system, of course we can accept a higher risk compared to a critical not redundant power line. The easiest strategy with the very high acceptable risk is the run to failure mode. So there is no planning, there is no maintenance action, there is no feedback from the asset, and we just wait for the fault and fix them. From this stage, when we want to reduce the acceptable risk, we can work on preventive maintenance. So we have a time-based maintenance plan or testing plan for the asset. Then we can have a predictive maintenance approach that reduces again the risk. So we try to get more information about the asset. We manage this data in order to reduce the risk failure. And the lower acceptable risk that we will find is when we have a maintenance that is based on the reliability of the asset. Of course, we will have an increasing data and information to manage when we move from run to failure up to predictive maintenance, and we can have different steps of information that we manage. For instance, we can have surveys, quite quick and easy check of the asset that can be done simply by visual inspection or by standardized survey methods that we can have in a substation like thermography or RFI. And if we want to have a deeper information on the condition of the asset we're going to test, we can have an investigation step that can be performed online with the partial discharge screening and the partial discharge test on specific asset. So we can be a little bit more specific, and we can build a test around the asset. In the end, if we want to move to a fully complete system that give us the highest quality and quantity of information to be used to decide our maintenance strategy, we can move to the continuous assessment. So we can have permanent monitoring of medium voltage cables or as well for high voltage cables. There are a few differences that will be described in the next slides. At this stage, we have our first pool. We will have a total of 3 pools, and my colleague Jessica will present to you the question. Please try to give an answer. It will be very interesting, your feedback from our side, also to understand what is the hot topic here.
Okay, thank you, Lorenzo. So let's start with the first question, that is, what is the biggest challenge you expect from underground cable testing? Financial resources allocation. Find a solution that fits the asset owner strategy. Take proper action based on the findings. Okay, so I'm seeing that you are voting. Okay, let's wait a few seconds. So 5, 4, 3, 2, 1. Let's close the pool and show the results.
Okay, thank you so much, Jessica. It's interesting that
You're
we
welcome.
have a first difference between the yesterday pool and today pool. So we can see that in Europe and related time zone, the biggest concern is about taking the proper action based on the findings, by far respect to the other 2 challenges. Instead, for the today's audience, there is basically a balance between find a solution that fits the asset owner expectation and take the proper action. So first information that give us some feedback on the customer expectation and on the experience that you have. Thanks a lot for answering the poll. We can go ahead, starting presenting the survey method. The first method that presented here is the thermography. we put it here, even if it's not, let's say, typical for underground cables. It's something that it's very popular in substation and can give us feedbacks as well on the cable termination. Those are present in the substation. So it's something that you can always find in a EMD toolbox, and it works with a very easy working principle that is the human eye image recognition. So it's quite applicable to everyone. There is no deep training or deep skills involved, and it's a quick thing that everybody can do without let's say a limited effort. As I told you before, cannot be applied to the buried portion of the underground cable, but we can have and also we have actually a good percentage of faults as well in the termination side of the cables. Those are exposed to weather condition and pollution as well. So we can have an assessment on the termination as well on the earthing system and bonding cables. We can see overcurrent flowing in the sheets thanks to the thermography of the termination boxes of the earthing point of the terminations. So quick test that is normally performed in substation and can be applied as well for underground cables components. A second survey method that we want to present is the RFI survey. So is similar to the thermography. It's a practice that is normally performed in substation. It's quite an easy test that can be used as a routine test. And we can find as well, for example, defect or partial discharge occurring in the cable termination by comparing the spectrum of the baseline with the spectrum nearby the assets. You can see here a few pictures about defect propagation, signal defect propagation outside of the cable termination. We can pick it up with a UHF antenna, and on the chart on the right you can see the spectrum of background noise with purple and with signal on blue. By studying such spectrum, we can have some information, first, let's say, level information, if we have unexpected signal in the asset we are testing. We have here some information about which kind of defect we can find with respect to their spectrum frequency and related the phase result PD pattern. So we can see that we can study some partial discharge phenomena or signals similar to partial discharge, not just by studying the PRPD pattern with the solid sensor like HFCT or capacitive coupler, but we can see something as well with antenna sensor and recognize them very easily. In this case study, it was a routine inspection on a substation. We have basically 4 detection points, the baseline noise just outside of the substation, and 3 detection points for the different location of the substation, place 1, 2, and 3. With the red line of the spectrum, you can see the baseline detection. And with the 3 different columns, we can see with the green place number 2, blue place number 1, and purple place number 3. We can see that with respect to the baseline, we have an increasing amplitude of the frequency when getting near to the place number 3. We can see that it was due some also surface discharges activity that we have easily recognized just by walking by the substation and taking 3 readings. One key point that can be interesting when speaking about surveys is that can be easily included in the routine maintenance of a substation. So we will have the local personnel of the substation that knows more or less every detail of the substation, taking this reading, and just by a direct comparison between the past readings and the new readings can highlight eventual problems occurring in the substation. Now we have the pool number 2. So I leave the audience to Jessica.
Thank you, Lorenzo. So here is our second question. What is your experience of substation surveys, thermal cameras, RFI, or other techniques? So let's wait a few seconds. We close the pool and show the results.
Thanks for answering the question. We can see that 50% of you guys have answered the question. Thanks for the participation. And as expected, thermal cameras are quite popular, and RFI second, while other techniques are not so popular for the audience right now. So we move forward. Let me just close the window, move forward to our presentation, and we move to a higher level of investigation. So for both medium voltage and high voltage cable, we will discuss about online partial discharge testing. The partial discharge assessment is a specific electrical test based on the signal emitted by defect in the insulation system normally. So we are talking about insulation problems. You can find even more information in our previous webinars for the high voltage cable, for instance, or for medium voltage cable, where we deeply explain the partial discharge application. At this stage, we want the partial discharge to be a part or a possible solution of the strategy. So what is the differences between the survey and with the RFI and thermal cameras with partial discharge? It's a more specific test because we are just investigating defect of the insulation. So it's quite specific. It's not limited to the termination, so we can also have an overview of the wall insulation system of the circuit. And we can use this test to be performed online without out of service to prevent some faults or to decide which of our lines needs a more accurate investigation by placing them out of service and performing some offline testing. And in some cases, we can also use them to localize defect exactly by the mean of a time domain reflectometry study of the PD pulse that we have. It's not, let's say, so much easy online because we have lower reflection properties of the media and we are working in a noisy environment, but in some lucky cases we can also localize exactly the partial discharge along our circuit. Depending on the layout of the medium voltage cables, we can perform a test at the access point that we have. So 95% of the time for medium voltage cables, the only accessible detection point will be from the cable termination sites. So we can be very effective in preventing faults in these terminations that we are testing. And we can also trigger measure defect coming from the cable. So we can see that there is a signal of PD coming from the cable route, even if we cannot exactly localize it. We can manage this information to be used accordingly for the maintenance planning. In some other cases, if we have very long lines, we can have even in medium voltage some link boxes. So we can test as well partial discharge from the link boxes, and we can cover the cable route in a more accurate way. In some rare cases like tunnels or industrial plants, we have the wall cable route accessible, so we can test the wall cable circuit even if it takes, let's say, a little longer time because we have to follow up all the cable, can be very, very effective. Let's see now the typical test that we can have in medium voltage. So if we have an air insulated termination, we will use a high frequency current transformer placed on the ground leads of the termination or directly around the cable. For example, you have the HFCT around the wall cable in the picture in the middle, while you have the HFCT on the ground lead of the termination in the picture on the right. It can be used as a first order investigation, so we can have in some lucky cases the PD localization, or we can just have the information that the system is PD affected. We can have some issues because of the noisy environment, and we have to consider that there is an attenuation of the signal for long cables. So if we are testing a 10 kilometers cable and there is a small PD event in the middle, by testing the terminations only, it is possible that such signal doesn't reach the terminations. So it's something that we have to take into account. If we have instead the gas insulated termination, we use HFCT on the ground lead where present. Otherwise, we have some flexible magnetic couplers to be used over the sheets of the cable. In this specific test, thanks to the GIS design, we have a very good signal to noise ratio. So it's quite a quiet environment for testing. When we have instead accessible joints or accessible cable routes, we can use UHF antennas to test the spliced joints directly, so we can place the antenna directly over the joint, or we can place a flexible magnetic coupler along the cable routes to cover properly all the length of the cable with a quite high sensitivity. Here we have a case study. I'm reporting a case that was presented at the ECPDM, the IEEE conference in 2021, using TechImp instruments. We're talking about a medium voltage GIS panel, and the measurement we're taking with HFCT on the cable. And this testing campaign was part of a routine screening of the substations. And since we can have quite a spread signal distribution along the common earth, it is quite important to refer the PD to the proper applied voltage, so we can study the phase resolved PD pattern, and we study as well the polarity of the pulse that we measure at each single detection point. There is also a rough analysis of the case study on this slide. On the left, we can see the test related to the HFCT on the three phases of the panel number 2. And we can see that there is a higher amplitude on phase L1 and reverse polarity for L2 and L3. Instead, on the column on the right, we have three PRPD patterns related to the test performed with HFCT on phase L1 for panel 1, panel 2, and panel 3. So we can see that when we have a reverse polarity on nearby phases, we can recognize the phase source. Instead, when comparing the data from the three different panels, we can localize the panel that is the source of the PD. We move now to the high voltage cable partial discharge testing. An advantage respect to medium voltage PD testing is that in high voltage, the layout of the system, the components and the design are quite standardized. So we will always have some key points where we can decide to use our sensor. And there are more information about the installation and the commissioning of the cable. The most critical component for the insulation stress in high voltage cable are the cable accessories, typically joints and termination. And we are quite lucky because in high voltage cables, these accessories always have their own detection point, may it be the ground lead of the termination or the link box of the high voltage cable joint. Some positive and negative aspect of the online spot testing. We are checking the system in the real working condition. We don't need any out of service. We don't need any external power supply. So it's a cheap and quick test. But we just take a look at the frame of the asset routine. We can have a noisy environment. And for the data analysis, we may need to have some skills and experience because For instance, if we are testing in a high voltage substation, outdoor high voltage substation, we will have all the disturbances from the corona and the surfaces of the outdoor components. Those will enter the measuring chain, and we need to differentiate between what is external from the insulation and what is internal to the insulation. That is the dangerous and critical point. Brief introduction of which sensor we can use in GIS termination. We can use a frequency current transformer on the ground leads. We can use UHF antennas on the insulating ring spacers of the termination, and take a look also at the upper portion of the termination that connects the GIS to the cable. We can use FM flexible magnetic sensor along the cable, and eventually some of these accessories have their own partial discharge sensor embedded, and we can take advantage of this sensor to perform a very sensitive measurement. An advantage of testing the GIS is that the background noise is normally very low, and we do not have, in case of GIS substation, all the external disturbances related to outdoor high voltage assets. When testing outdoor termination, we can use as well the HFC high frequency current transformer on the ground leads, or we can take advantage of flexible magnetic couplers along the cable and eventual embedded sensor. A key point for outdoor termination testing is that the outer surface of the termination itself can be a source of external surface partial discharge. Those are partial discharge signals, but they are not occurring inside the insulation. They are occurring in the creep edge of the termination bushing. So it's something that is less dangerous respect to a partial discharge that directly involves the insulation system, something internal to the insulation system. For this reason, we need to separate different PD source and properly identify the PD sources. In case we have tunnels or manholes with accessible joints, and the joints are armored, so we are in a safe condition to enter the place, we can use HFCT on the single bonding cable, single core bonding portion of the concentric cable that goes to the link box, or we can use the flexible magnetic coupler over the joint and over the cable. A key point that is a very big help for the testing engineers when testing high voltage joints is that normally the joints, especially for long circuits, are far away from the termination of the cable. And the termination of the cable are the only places where we have external disturbances entering our measuring chain. So we expect a very good signal to noise ratio in the joints, and we do not have to fight against external signals and disturbances. In case of an accessible joint, we always have a second chance. The link boxes of the cable bay of the joint base are always accessible. The link box is where we have the concentric bonding cable coming from the joints, entering the bars, and we can have then a straight configuration of the bars or a cross bonding configuration of the bars. By placing an HFCT on the bonding cable directly, we have a lower sensitivity, but we can pick up anyway a signal, so it can be very useful for a screening to be sure that there is something, or there is a PD, or just a signal to noise, or just background noise. It's always possible to do that. We only need to access the pit where the link box is placed. Here we have a case study about GIS cable termination. The customer called us to perform a survey, so a PD screening of all the cable termination of a 20 to 20 kV substation, and it was possible to find PD in the GIS termination. It was then inspected, and the new stress cone was placed instead of the defected one. Jessica, can you please now go for the last pool, the pool number 3, since we are moving forward to the last steps.
Yes, so now it's your turn, and here is our last question. Based on the presented techniques, What can be a suitable solution for your needs? PD test on MV cable terminations, PD test on HV cable terminations, or PD test on HV cables, joints, link boxes? So I'm seeing that 40% of you are voting. Okay, just a few seconds. And 5, 4, 3, 2, 1. Let's close the pool and show the results.
So it's very interesting. Even in this pool, there is a strong difference between the yesterday result and the today result. Today, the hot topic is the medium voltage cable termination test, while yesterday we were more the audience was more interested in high voltage cable joints and link boxes. So let's move ahead to the monitoring solution that can be used for medium voltage and high voltage cables. So for medium voltage cables, we can monitor three main things: partial discharge, ultrasonic signals, and temperature at determination. Normally, it's hard to have something that is distributed along the medium voltage cable line. So we have as an access point for detection the terminations only, and we can have a better survey by analyzing these three parameters. Here there is the user interface of our monitoring solution for medium voltage cable termination monitoring. There is temperature, PD, and ultrasonic signals. We can have dedicated alarm for each of the single step. We can now take a look at a case study related to a similar case. So PD monitoring on a medium voltage cable termination. We do not have any ground available, so we have to put the HFCT on directly around the cable, and we have acoustic airborne monitoring determination. Our standalone unit for medium voltage testing detected a PD activity on one of the cables, and this information was then managed by the user. So here is a good explanation of what we mean by designing the strategy for the results of the finding. For this specific company, the policy is to have zero partial discharge activities in the network. So the idea was to have a monitor that, starting from a zero PD situation, triggers alarms only when we have new phenomena occurring, and there is an action plan for this PD detection that is composed by several steps. First, there is a confirmation of the PD from the customer expert. Then there is an out of service offline PD test for localization. Once the defect is localized, there is visual inspection and maintenance to the program. So you can see how the structure of the maintenance has its own advantages, and it was a very efficient way to manage the information received and to plan proper activities. When we move instead to high voltage cable monitoring, we can have a little bit more complex systems involved. Of course, the big advantages of the permanent online monitoring is that we have continuous information flow, we have a lot of data trends, and we have automatic alarms triggered. On the other side, it's a huge investment. We need to have follow-up resources dedicated to the analysis of the alarms and to take action respect to the alarms triggered by the system. And the installation of the devices for the monitoring can be tricky and complex. So what can we monitor on high voltage cables? We can monitor partial discharge, we can monitor temperature, acoustic signals, sheet currents, and other in some cases we have some specific cases where our monitoring system included, for example, infrared cameras from the manholes, SVLs monitoring, or oil pressure of determination monitoring. A key point for the permanent HV cable online monitoring is that we need a lot of hardware. For instance, we need in each link box partial discharge and sheet current sensor. We need a fiber optic that runs along the cable route for communication. And we need a good and reliable power supply. In some cases, it is possible to bypass the problem by using standalone power supplies with solar panels or 4G communication instead of fiber optic, but this is a case of retrofit, so it's normally quite last resort solution, and it's quite much more expensive respect to having a fiber optical on the cable and a power supply line. This is, for example, the PD monitoring hardware required. For each link box and for each termination, we will have sensors connected to an acquisition unit. All these acquisition units are connected to each other and to a central unit with a fiber optic, and all of them must be energized from a power line. All the signals were sent to the central server that will be then analyze the data, provide the alarms, and connect to the customer communication systems. It will be very nice to have a PD monitoring because we have a quite continuous check of the system for each detection point. We can customize alarms based on the amplitude, based on the identification of the signal, and based as well on the frequency component that we see in the signal. And everything comes out with a very nice and easy to understand web application. That is a map of the cable with a different test point and the related traffic light alarms. Instead, when we move to distributed temperatures sensing and distributed acoustic sensing, we take advantage of a specific fiber optic installed along the cable or embedded in the sheet of the cable. Such fiber is combined with a laser source and an analyzer. And by taking advantages of the phenomena occurring in the fiber optic in the material, it is possible to study the response of this material to the laser source thanks to the analyzer, and we can have the whole fiber optic as a unique linear sensor, so we can address each position of the cable with a very good, very low uncertainty, so we can talk about meters range. For the temperature sensing, we take advantage of the behavior of the fiber optic material. So when we have a laser injected in a fiber, there will be a scattering of this light, and such scattering is characterized by 3 different spectra. The relay scattering that is related to the wavelength of the laser source. Then we will have stoke components, those are shifted in lower frequency, and anti-stoke components, those will be shifted in higher frequency. The anti-stoke components will be influenced by temperature. There is a huge work behind the optoelectronics metrology, and it is possible then to address the single temperature at the single meters of the cable route thanks to this dependency of the anti-stoke components from the temperature. Similar to the temperature sensing, the acoustic sensing takes advantage of the relay backscattering and give us information from the vibration occurring in the cable. We can see, for example, in this video, PD localization performed on a cable, where we can see how it can be effective having a vibration acoustic monitoring in a cable to hotspot directly the place where we have to dig to find the fault. So we can take advantage of the DAS for cable faults localization. It can give us information if there is unwanted manual or mechanical digging nearby the cable. And we can have as well unexpected vibration due to interaction from works, from trains, and so on. Last, there is also the sheet current monitoring, so we can study the behavior of the grounding and the sheets connections in the cable. We can prevent wrong bonding system installation, resistive connection in the link boxes or in the termination boxes, faulty surge voltage limiters or flooded link boxes, and sheet faults where there is a low earthing resistance. Unfortunately, you cannot use this method is not so effective when we perform spot testing because the sheet current simulation are not so easy compared to the real condition. So we can have since there are so many parameters involved because of the installation, we can have some dubs when taking just a single acquisition. A very good information comes instead from a permanent monitoring system where we have all the sheet current recorded and trended. We can correlate the historic values with an alarm, and we can as well correlate the recorded values of the sheet current with the line currents. That is a big impact on the sheet currents themselves. So in the end, making a brief summary, what are the challenges that we find when building diagnostic strategies for underground cables? First, we need to evaluate the risk of the system. This evaluation can be done by the experience of the past from the asset. So we can study the history of the asset. We can have information from the literature, and we can take some information as well from the standard and regulations applied to that specific asset, like EAC or SIGRE or IEEE. At this stage, we can then set up a maintenance strategy. So we will decide which risk we can accept, which strategy we can put in place to reach that target, by exploring then the possible solution for the specific cable line or for the wall fleet. Then we can plan such testing session or some system installation accordingly to the previous evaluation, so the risk, the strategy, and the solution. And in the end, we will also need to build an action plan based on the possible output from the underground cables diagnostics in order to enhance the efficiency of the diagnostic techniques put in place. So this was the last slide. I kindly invite you to, if you have questions, to put them on the GoToWebinar chart. I can see that right now there are minor, let's say, there are no questions, just single explanation. We will send the webinar presentation can be downloaded from the website, answering one of the questions. And we have no other questions coming. We wait maybe a few more minutes. Which kind of PD usually found on the cable termination? So in cable termination, we have you can find in the end all the three big families of cable of partial discharge, but you have to address them properly. We can have coronal discharges occurring because of an improper clearance installation or an improper or dirt or pollution and other problems in the cable termination enclosure. We can find surface discharges. Those can be external to the insulation or occurring in a surface on an interface between two different layers. For instance, between the semiconductive and the XLPE, or between the semiconductive and the air itself. Or we can detect as well internal defect from the XLP portion of the cable. Those are the most dangerous from our experience, and those shall be localized precisely, hopefully with the time domain reflectometry. What are acceptable limits of PD in underground cables? It's not an easy question to answer because we are no more in laboratories. We are not more in a calibrated environment. We cannot express picocoulomb values. So we need to be, let's say, a little bit adherent to the situation. For high voltage cables, our policy as when we perform the test is to do not have any PD. So zero PD policy for high voltage when we talk about 132 and above. For medium voltage cable, based on our experience, we can, let's say, have PD occurring for quite a long time, but in this case, we do not talk about the level of the PD or the value. The information is that, look, there is a defect. This is the information that we have to provide to the asset management. We have a defect in the cable system that can lead us to a failure. It is hardly impossible to prevent exactly the number of days that we have before the failures. It's an odd topic that everybody would like to do, but it's mostly impossible, especially for medium voltage, because there is so much different design and materials used. So we do not talk about medium voltage cable acceptable levels, but we talk about information that we can find from the measurement and related action that we can take. Is there an inspection method to find water ingress inside of HV cable joints? Not with the partial discharge. I will try to look if it can be, let's say, addressed with the acoustic monitoring. But from my direct experience, that is more on the partial discharge. It is not possible. We'll come back to you with a more definite answer via email. Another question about the maximum PD expectable on HV cable. In HV cable, we do not want to have any partial discharge. Since we have such a strong voltage stress, and since the XLP is fragile respect to partial discharge phenomena, the acceptable level for PD in high voltage cable from our experience is 0. Which method in medium voltage support the evaluation of the distance to the fault? I guess that the question was the evaluation of the distance between the detection point and the source of the partial discharge. And we have, first, the more accurate way is to have a time domain reflectometry, but we can have issues due to missing reflection because we are in the online condition, so the reflection will be lower because there is a big transmitted portion of the signal. Instead, when we go offline, there is everything is reflected by the system. And another method that we use a lot that give us a very big success is the analysis of the partial discharge pulse component. So study the PD pulse in terms of frequency component can give us a very good overview of where is the partial discharge respect to the detection point. Let's see if we have a few more questions. Which method is best for measuring PD on cables? PD survey or HFCT? If we want to test the cable, the wall cable, HFCT is for sure the testing accessory that gives you the highest information when we can test at medium voltage termination only, because the RFI survey will be a little bit more limited to the termination only. Instead, by using the HFCT, we can take signals coming from the cable as well. How long will a cable last underground? Well, in my experience, I've seen cables placed in the 60s still used by the utilities. But if I'm not wrong, right now the expected life of an high voltage cable XLP is around 20-25 years, the expected life. When we talk about longer lives, it's because of old cable design with, for example, oil-filled cable or oil impregnated or paper impregnated cable technology. Those were, let's say, a little bit more uh, hard to install, hard to fix in case of fault, but they can last longer. Obviously, the price was much, much higher than XLPE. We need to measure PD on bus ducts. Okay, very nice, but this webinar is on underground cables. We can give you some information about our experience in bus duct privately. Which is the best sensor for medium voltage cable, capacitive coupler or HFCT? Since again we are talking about what we can do online in this webinar, so online the best information is for sure from the high frequency current transformer because it covers the highest portion possible of the cable, and we have a quite good PD pulse information. Is there any other question about underground cable diagnostics? One question about sheet current values. So sheet current are, the question is sheet current are a variable test value. It's the combination of, it's affected by the combination of several aspects of the cable and of the installation and of the load. So the best way to study the cable sheet behavior is to use the monitoring data and to understand what is the normal value at the very beginning of the life of the voltage cable, and to study the behavior over time of the same sheet current respect to the line load, for instance. Okay, I would say that our time is almost over. Let me share with you the calendar of the upcoming events. We will have a very, very interesting webinar hosted by my colleague Tony from Double, creating and using meaningful asset health in indexes. Then we will have the same one for Asia and Pacific on the 15th of February. I strongly suggest you to participate. And the other ones are not, let's say, for Asia Pacific, they are in Spanish and German. But I strictly suggest you to follow up the meeting, the webinar on the 15th of February, and to keep an eye on the next Altanova webinars that you can find on the website. For today, I guess we are over. Thank you so much for all the attention. If you have a further question, do not hesitate to contact us. You can download the presentation from the website together with the video. And here there are my contacts, or in the website you can find the local office that can follow up you directly depending on your region or country. So Jessica, I think we can close the session. I'd like you to to greet as well our audience and invite them to the next events. If I'm missing up something from the website information, please feel free to complete my statements.
Okay, thank you, Lorenzo. Thank you, everybody, for your participation.
Goodbye, see you next webinar.
Bye-bye.